Hello everybody, so look, we're looking at redox equations again in terms of titrations, and it's only going to be for the maths. And again, it's just a maths overview, so that means we're only going to be looking at what formulas we're using and when we're using them, opposed to actually doing them out. And if you want to see the full workings out, you just need to go onto the experiment section there on the conical flask, and you'll see the maths and chemistry and the entire workings out. So this is 2011, and it's on Bleach, and we're only going to focus on the maths. So that means E and F are the ones we're going to answer. So we're asked in the first one, and we usually ask for this for Bleach, is to calculate the concentration of NaClO in terms of moles per liter. Moles per liter meaning molarity of diluted bleach and then the original bleach. Okay, so let's start off with the formulas we could use. So one formula we could try and use, so molarity equals mass per liter over the mor. Okay, we're not given a mass anywhere though in any of this here. Okay, there's no masses whatsoever, so we can't use this formula at all. Okay, so that's no good to us. So we have to think of something else. Now, we could also use it for liquids. Another one there, number of moles equals your molarity times the volume over 1,000, and you could manipulate that to get what the molarity is, but you'll find that yes, we have the volume, and thousands is obviously going to be a constant. We won't be able to figure out the number of moles. There's no form we can use to figure out the number of moles without requiring the molarity of something beforehand. So this equation is also a dead end. So there's one other one that we often use. Okay, that is our V1, M1, N1. Now, this is a little bit tricky, in which some students mix this up because we have two equations going on here, and often they don't know which equation to use. Well, it's always the second one. Okay, it's always thiosulfate against the iodine, and I'll explain why now in a second. Let's just fill it in first though. S2O3 2 minus, and over here we have our I2. And again, we have the same headings as we usually do. So V1, M1, N1, and we have our V2, M2, N2. Okay, so let's see what we have. The S2O3, if we look at it there, there's no mention of S2O3 here at all. Okay, we can skip that. And if you go down to here, we can see that we have a 0.1 molar solution of sodium thiosulfate. Okay, so we can write down 0.1 straight away. Average volume of sodium thiosulfate was 16.1. So we actually have our volume as well. And we can see over here that we have a 2 in front of us, so we put a 2 here for our N. If we look at our iodine, we can see there's nothing in front of it, so we can assume it's a 1. Let's see, what else have we got? How do we know how much iodine are we using at all? Okay, so we'll figure that one out now. And if you read back to the original part of it over here, it says a 25 centimeters sample of bleach was diluted to 500. We don't need that part of it though, but we do need this part here. Pipette was used to measure 25 ml of the volume of the diluted bleach and transfer it into a conical flask in which Ki was added. So we can actually assume that the Ki over here is going to be, that the I2 is going to be 25, because that's how much they put into the conical flask. And we're looking for the molarity. Now, we're looking for the molarity of I2. And you might be wondering, why isn't it bleach? Because bleach is mentioned up here. But we can see here straight off that we have our formula there for I2 is to ClO minus. If we're using half formulas, it's 1:1. The ratio is the same. So if I got the molarity of I2, well, the molarity of the bleach ClO minus is going to be the exact same. So that's why we use this formula over here, opposed to the one over here, because we don't have the volumes or the necessary details for ClO minus. Now you put that into your normal formula there, and when you do that out, you're going to get the molarity. Your molarity then is 0.032 moles per liter. Okay, so we'll highlight that there now, and we'll look at, now, just to make a quick note of that, actually that is our diluted bleach. So if we're converting that, we want to go from our diluted bleach to original bleach. All we need there is the dilution factor. How many times was it diluted by? So let's have a look. We're told up here in the original question there, a chemist determined the concentration of bleach containing NaClO by volumetric analysis. A 25 centimeter cube sample was diluted to 500 centimeters cubed. So how many times does 25 go into 500? Okay, so that's going to be your dilution factor there. Okay, and if we just get out my calculator there because I don't have it done myself, I will need it for next part. 500 divided by 25 is 20, obviously. So that's 20 times. Therefore, 0.0032 times 20, okay, is times 0.032, and that will give us 0.64. And that's moles per liter again. And that is of our original bleach. Okay, so we have the maths done now for this. We have the diluted bleach and we have the original bleach for part E. So E is done. Okay, grand. Okay. So what I'm going to do there now is I'm going to get rid of all of this. I'm going to need the space. We'll refer back to it later on if we need to. So we're asked here in part F, part I, what is the concentration of NaClO in the original bleach in terms of grams per litre? Well, we go back to our normal formula for that. Whenever you see grams per litre, really you can just do molarity equals your mass, which is obviously measured in grams per litre, over the mR. Therefore, your molarity times the mR equals this in grams per litre. And then we can just figure out what that is. Now, read what we're looking for. We're looking for the original bleach. So we put in our values for what we had there for the original bleach, and it was 0.64 times. Now we have to figure out what the mR is. Now, we're looking for the mR of NaClO. And if you did that out correctly, okay, you're going to guess 74.5. The chlorine there given the 0.5 part of it. And if we do that out, then we'll just write it out there now. It's going to be 47.97 grams per litre. And that's your answer for the first part, for I. And now we're looking for it in terms of the percentage, in terms of weight per volume. Now, as soon as we see weight per volume, it's the exact same as previous ones. Get it into grams per 100 centimeter cubed. Okay. Once you have it in grams per 100 centimeter cubed, you're done. So let's have a look at it. We have it in grams up here per litre. So how many times does 100 go into 47.97? Oh, sorry. How many times does 100 go into 1,000? A litre being 1,000 centimeters cubed. Okay, it goes in at 10 times. So your 47.97, if we divide that by 10, we're going to get our 4.7 grams per 100 centimeters cubed. And therefore, we can assume that 4.7% is our answer because we have it out of 100 there. So 4.7% is the final answer here. So just to recap on that one there, this comes up a lot, maybe not just in this experiment, but in a couple of experiments. The first one being grams per litre. Okay, just use the form that we have over here. Molarity times the mR equals it in grams per litre. Grand. That's fine. And remember, just to use the original bleach for that. Okay, that's a common enough one that comes up loads. And then your next one then is your percentage. As soon as you get it in terms of percentage and weight per volume, always put it out of 100. So grams per 100 centimeters cubed. And that's it for this one. Okay, there's another one we'll practice now in a moment. All the best.